Professor, thank you for joining us. My first question is about your research direction. After you winning the Fields Prize, you switched your research direction from number series and analysis to Topos series. Why did you make that change?
Okay, so in fact I have a very long story with Grothendieck Toposis and with Grothendieck himself. So I discovered the work of Grothendieck when I was a student at École Normale Supérieure, that in algebraic geometry there was a giant who was Grothendieck. And so I remember I borrowed at the library the whole collection of books by Grothendieck and his school, which gave new foundations for algebraic geometry. It took me several years to read these new foundations and to understand them, to begin to become able to work with them. And in this huge work of Grothendieck, which was like a new continent, in particular there were toposes. So toposes had been introduced in mathematics by Grothendieck as the most general or the most natural setup to develop and study so-called cohomology invariants, which are invariants coming from topology. But thanks to his discovery of toposes, Grothendieck was able to understand that these invariants, cohomology invariants, existed well beyond was thought before. And in particular, he was able, thanks to this discovery, to introduce new cohomology invariants in algebraic geometry. So a completely new theory, completely new tools, which enabled not only him, but many people after him, including myself, to prove a whole series of very deep results. And then in, I think, 2011 or 2012, I met in my institute, so IHES, Institut des Hautes Études Scientifiques, I met there a visitor, a young visitor, so Olivia Caramello, who had just defended her PhD thesis in Cambridge on the subject of Grothendieck toposes. And she began to talk with me, and I discovered, thanks to her, that the world of toposes was even more rich than what I had thought before. Whereas before I only knew the relationship of toposes with geometry. But then I discovered, thanks to Olivia Caramello, that already in the 1970s, some so-called categorical logicians had proved some very general theorems, creating a very deep link between logic on the one hand and toposes on the other hand. And I was also very impressed by the theory Olivia Caramello herself had introduced in her PhD thesis under the name the theory of toposes as bridges. In fact, her theory, which was based on Grothendieck toposes, was a general theory of relations between different mathematical theories. The fact that it may happen in mathematics that some seemingly completely different theories in fact tell the same story. So this was all the more interesting and fascinating for me, as I had worked for many years on the Langlands program, and the Langlands program is an incredibly deep example of a relationship between different mathematical theories. What I discovered thanks to the conversations, the exchanges with Olivia Caramello, was related in many ways to what I had done before. I mean, both I had used all the time Topos theoretic invariance, so cohomology invariance, and I had been working on a particular, but of course extremely deep example of relationship between different theories. And then, thanks to Olivia Caramello, I understood that that many relations between different theories could be studied in the framework of mathematics. So this means that I understood that Topos theory allowed to do mathematics at different levels. And this is how I became interested in toposes more and more. Quite many years later, I met people from Huawei, also by chance. But when I remember very well that I gave a talk for Huawei engineers because they had invited me, and I decided to talk about toposes. I didn't expect at all that they could get interested into this subject.
A very interesting story, and I think your experience proved that in science and engineering area, communication is very important. You know, which Chaspark has a slogan, inspire spark and inspire creative, and your experience proved that.
Yeah, exactly. So communication is extremely important, and in fact, it is more and more problematic because mathematics, in particular, and science in general, grows all the time. And as it grows, of course, people know less and less in comparison with everything which exists. And so it may happen that developments which could be extremely interesting for what you do exist elsewhere, but you never heard about them. And so, for that reason, we need some luck. The luck to meet some interesting people, and for these people to talk to us about interesting things. But this, in some sense, it cannot be predicted. And in the story I just told you, in fact, several times, things happened by luck.
Could you please share with us your current research?
So, in fact, I can say that by now, inside Huawei, I have myself become some type of bridge. I mean a bridge between theoretical science, pure mathematics, abstract mathematics, and engineer work.
Yeah.
So, on the one hand, of course, I still keep many relations with the academic world. So, I have the relationship with all this theoretic work being done, but at the same time, I talk every day with people inside Huawei who try to solve concrete problems. For most of them are engineers, especially telecommunication engineers, computer science engineers, these people, but also mathematicians. By now, there are other mathematicians working inside Huawei, and here I have discovered that the world of pure mathematics and the world of applications are not at all as far away as I thought before. I am still baffled to see that engineers may be extremely open to abstraction, to general theories. Engineers may be more interested in general theories than many pure mathematicians from academia. Because in academia, people usually try to solve very difficult or extremely difficult special problems. Whereas engineers are more interested into the basics of general theories. Because what they need to do is to understand the most fundamental facts of general theories and to try to implement or to use these facts for implementations in a concrete way. So it is not the same spirit as pure academia. And so by now I am a bridge between these different ways of thinking and also between different people. So on the one hand, I have some joint work, in particular with Olivia Caramello, but at the same time, for instance, I give talks regularly for people inside Huawei. And for instance, in the last month, I gave a whole series of talks on the question of so-called syntactic learning. So there is a general framework which is inspired by Topos theory, but then, of course, what we are interested in is to make it work. We need ideas, and the ideas come from the theory. But then we need these ideas to be implemented, and then, of course, what we need is to jointly work with people able to write codes, to implement things in machines. So this I don't do. So, but I exchange with these people, and so basically every day.
Thank you for your sharing. Some people say they don't believe Huawei has mathematicians. And you not only help us prove that Huawei has mathematicians, and also we have the world's best mathematicians. And also prove that mathematicians can help Huawei to get progress in technologies. It's very inspiration, you know.
Maybe here I can add that I think it is a general pattern we can see presently in the world in the development of technology. For instance, by now we can see that all over the world, in some sense, there is a competition between academia and companies to recruit mathematicians. So before, if you were a mathematician, you could work for a company if you were working in numerical analysis or probability, statistics, this type of thing. But by now, it has become much wider than that. So it can also be commented that it seems to be Huawei is really at the forefront of this evolution.
Yeah.
So it is especially interested in fundamental research. Yeah. It is ready to invest in fundamental research.
Yeah.
Because, you see, I think that there is an understanding that real progress can only come from deep theoretical understanding. So we need new theories in order to make real progress.
Professor, you mentioned a very important topic, the fundamental theory research and engineering practice. I remember the last July, we invited you and Professor Ma Xiaonan, Professor Ma Xinan, and Dr. Ri discussed about this topic, in which you mentioned that top theories can provide explanation and optimization for AI. We want to know what the research progress about this direction.
Yeah, so it is not only a question of providing explanation. It is so what we are really aiming at is to have more efficiency.
Okay.
So we think that, of course, when you are a theoretician, you are looking for understanding. But when you are an engineer, you are looking for something which works better. But then there is a miracle that usually when you get better understanding, you become more efficient.
Yeah.
So presently, so we have several directions of research. So there is one direction which in some sense is more advanced than the other, which is the direction of syntactic learning. I just said, because here there is a well-defined, a well-phrased theoretical scheme, and it is presently being tested on examples. In particular, a direction which is most interesting for us, which is the direction of assistance, automatic assistance for mathematicians. For instance, automatic theorem proving or automatic research of results. You see, so of course, by now, it is not realized as we would want it to be realized. And for this big project, we need to have a whole team consisting not only of mathematicians, but also of computer scientists, which can understand what mathematicians say.
Yeah.
Because of the state of their knowledge, most of the time they make use of computers on the basis of the mathematics they know. So here, what we need is, in some sense, to enrich the amount of mathematical knowledge of the computer scientist we talk with, in order to make them realize that they can try to implement larger schemes. And here a lot of time is needed just to, it is not immediate, but let's say syntactic learning is something which is presently being implemented. Automatic theorem proving is more, it is a longer term project. And there are other directions, so an even deeper direction is the direction of so-called semantic information. So we need, in general, information theory needs a theory of semantic information. Topos theory provides the mathematical language which can be used to build such a theory. But here everything is to be done. Because information theory, as it exists presently, doesn't deal with meanings. So you see, it is. So here we are really in a situation where we understand that theoretical work can have huge consequences. But you see, it is not implementing a theory which already exists. It is creating a new theory. And this takes time.
Professor, do you agree with this opinion that AI and large models seem to be changing the world?
Yeah, what I can say is that so the present results of AI, at least for some applications, are very impressive. So I have been impressed already for a few years, for instance, by automatic translation systems. And at the same time, it is frustrating because, so from the point of view of a mathematician, present AI is based on very simple mathematical ideas. So in particular, the idea of composition of functions. So it is something which appears all the time in mathematics. You already learn about compositions when you are in high school. And so here we have a striking example of the fact that for engineers, usually, they need science, but what is most important for them is in science is basic science. They try to implement them concretely. And sometimes it works amazingly well. So for instance, these large language models, it is really amazing. But it is all based on approximation of functions by using composition. You construct an approximation as a composite of simple functions, one after the other. So in some sense, composition is something completely basic in mathematics. You could even argue that it is a pre-mathematical idea, because all the time we, as human beings, realize things by steps. If we want to do something, usually we have to decompose this in several steps, and then we know that first we have to do this, and then we have to do that, and so on. For instance, you are asking me questions, and I try to answer your questions. But I answer your question not by one sentence, but by a series of sentences. You see, I am just composing sentences one after the other in order to try to convey a meaning. And all the time we do this. For instance, in the morning we wake up and we have to go to work. So we need to go that, for instance, by walk. But what is walking? It is making one step and then one other step and so on. You see, a composition of steps. And large language, so present AI is an implementation of this idea. But of course, a computer implementation of this idea. So it is extremely basic. But it is amazingly efficient.
Do you think will AI with large models can bring new paradigm to the mathematics theory research?
Yes, a very big problem of mathematicians and scientists is that we don't know most of what has already been done.
Okay.
So here you could dream that AI could help you to identify other pieces of knowledge which are interesting for you, but which you never heard about. So maybe, and probably it could be helpful for that. And so this is a possible way. Of course, so I also mentioned that so we are interested in the problem of automatic theorem proving and of course proof checking. Okay, but in fact, quite many people work on that around the world. There is little progress being done. So it will depend on how much progress will be done. So for instance, something which could really help mathematicians is the following. It is the fact that mathematicians often make mistakes. Because when you write a mathematical text, so you write statements and you write proofs. But you can make mistakes. And when we write, we don't write everything. We just, what we write is always, in some sense, it is always a sketch. It is, you don't, you are just writing the main arguments, but you don't make explicit everything. So this means that mathematicians often make mistakes. Of course, after some time, they realize that there is a mistake here or there, and the mistakes are eventually corrected, or hopefully they are eventually corrected. but it may take time. It may take years. It even happened for some papers that people realized there was a mistake at some place 30 years after the paper was published, you see. And so you could imagine that a good AI system for mathematicians could help to check proofs. So presently, there are proof-checking systems, but they require mathematicians to transform first their proofs in a formal sequence, formal writing, very different from what they had written as mathematicians, and it requires a lot of work and a lot of time. So it is difficult to do it. But once it has become a formal system, it can be checked by a computer. But you see, the translation from the usual way mathematicians write to a formal version which can be checked automatically. So this is a very long process. Yeah. And so this means it can take months or even years. So here we could hope formalization, in some sense, for an automatic way of transforming mathematicians-like statements and proofs into formal statements which can be checked. Yeah, so this would be another possible and useful implementation of AI. Yeah. But once again, so here so people are working on that, but it will require time. And I think there is also the idea. You see, we are talking about applications of AI to mathematics. And in fact, this problem is interesting for mathematicians, but not only for mathematicians. Yeah. So for instance, Huawei is interested into this problem. But why? This is because many people think, and it seems quite clear, that if we are able to do this, we would be able to do many other things. Yeah. So, in fact, in the present state of things, for instance, if we think about famous large language models such as ChatGPT, for instance, if you ask a mathematical question, you get a very bad answer. Yeah. It doesn't work at all for that. So this means that the system seems very impressive for many other things, and for science, it is, especially for mathematics, it is very bad. Well, so this means that it is not at all at the level of human thinking, because we, human beings, are able to do mathematics, but ChatGPT is not able.
Yeah, I think it's a long way to progress.
Yeah, it is a long way. It is a long way, but it is very challenging. So here, this means that, you see, so mathematics is everywhere, because here we understand that if we are able to design automatic system to help mathematicians, it would have far-reaching consequences. But in order to do that, we need more mathematics. Yeah. Yeah. So mathematics here it is a challenge, but it is also what you need to make progress.
Yeah. So we can say the mathematics is fundamental for technology progress and society progress.
For sure it is.
Professor, you mentioned that fundamental theory research is a very powerful strength for technical progress and also the society progress. So would you like to give us some suggestion to China how to improve the overall ability in mathematics?
Yeah, so it is. No, anyway, what I can see is that China as a whole is making progress very, very rapidly because you see there is huge investment in education, in universities, in science, in particular in mathematics. There is also the fact that Chinese people value education and science a lot. They are very hardworking. Thanks to all of this, of course, there are results. And you can see more and more of them. So, of course, I have talked with many Chinese people about problems of teaching in science, in mathematics, and things like that. And yeah, it is difficult for me to voice an opinion. Maybe because so in order to design or to a very good teaching system, two things are needed. First, of course, you can study the education system of other countries, not only today, but also in the past. And, but of course, every country, every culture also has to take care of specific characteristics. So it is, you see, I cannot talk for Chinese people. I can only say that, for instance, but I can talk on the basis of French experience. And I can say that in France, and also in other European countries, but especially in France, for many centuries, the basis of education was so-called humanities. So this means ancient languages, literature, philosophy. And only after that, some people became interested in mathematics or science, but the basis of their education was very much on the humanities side. You see, on the basis of French experience, I would say that it would be a mistake to completely split humanities on the one hand and science on the other hand. So, for instance, when you write mathematics, you write. A mathematical text is a text with words, with sentences, and in fact, when you think about mathematics, you think about formulas, computations, and things like that. But not. Of course, it does exist in mathematics. But if you open, for instance, a mathematical, professional mathematical journal, and you just look at the papers being published, they consist mainly in words. A mathematical paper, a mathematics book, consists mainly in sentences, in chapters. In some sense, it belongs to literature. So, I think that this relationship with language and so with literature is very important. You see, that in fact it would be a mistake to consider that a mathematician is only a super technician of mathematics. So, of course, you need technique. You need that. But mathematics is also thinking. And we, as human beings, think with words. We think with language. So the relationship with language is very important. And so, for instance, if I have to talk with Chinese people on this question, I tell them, so you have all this legacy of several thousand years of Chinese scholars, Chinese writers, Chinese poets. This is most important. even for the development of science and mathematics. And you see, what I can say is that at least in Europe, and especially in France, for many centuries, mathematics and science were developed on the basis of so-called humanities.
Yeah, I got it. You know, I remember Steve Jobs once said, the innovation occurred across of technology and art and society, social science. I think it's similar with your opinions.
Yeah, and in fact, Steve Jobs, I remember an interview I had read, so he had given, he was talking about the education of his children. And so he explains that at home he didn't want his children to spend too much time with computers. You see, he talked to them about Shakespeare and you see. So this is, I had been very much stricken by this interview.
Yeah, I think I understand your opinions. Mathematics is not a technical, you know, about a human philosopher and other. Yeah. So you can understand the why. So you can do how.
Yes. Yeah. You need. What literature and philosophy and the deep study of language can give you is the ability to think. And then, when you tie this ability with technical abilities, you can become really a mathematician.
Professor Machinan mentioned to me several times he is so respectful your efforts for China French mathematics talents class, and he said you are the leading promoter of this class.
I would say much less than him, but he is a real force behind all of this. So,
would you share with us, is there any future plan of this China French mathematics talents class?
As far as I know, the present plan is just to keep on running the program, this class. So I understand it is very successful. In fact, here in France, I meet regularly Chinese students who had been students of this program. So by now they are in France. And I can see that they are very happy because you see, they had learned French in China. They had even studied mathematics in French. And so when they arrive in France, they know they can talk French with other people. They are very strong in mathematics. Even most of the time, they are stronger than French students, so it has to be said.
Really?
No, because you see, in China, all these students are, of course, they have been selected, so they are among the best students. And as everybody in China, they are very, very hardworking. So they learned a lot. And I know, I learned from the French professors teaching to them that they are extremely happy giving these lectures in China at USTC because the students are so good. And so they teach more to the students in China than they would in France. And so when these students arrive in France, they know a lot of mathematics in particular. They also know a lot of physics. And they speak the language, so this means they can interact very easily with the whole society. And the people who welcome them have admiration for them because they were able to learn French in China. So it is amazing. And so I think that they are most welcome in France. People are, so the professors are very happy with the students. And of course, an important element is that, so of course, they are students, but after that they will become professors or engineers or many different things. But they will also be living ties between China and France. And it is very, very important. So I am very happy to be part of this program. And I really admire Professors Xiaonan and Xiaxinan for what they have done, and also other people involved in the program. In fact, this program works because there are many people deeply dedicated to make it work. And both on the China side and on the France side. It could be imagined that this program becomes bigger. By now it is at USTC, I think it is approximately 20 students a year, but it could be more, and so you see, so anyway in China there is such a huge potential for education. It is, yes.
Are you still ride bike to work?
Yeah, of course. I have my bike is just undergone. But it is there, of course. Yeah. You have remembered that.
Okay.
You have good memory.
Thank you so much.
No, and many thanks to you. So your questions were very interesting, and it was a great pleasure to have this exchange with you. Thank you very much. Thank you very much.